Now that we've learned how to graph inequalities in two variables, so on a coordinate plane, now we're going to graph systems of inequalities. So remember, system means that we have two or more that are solved together. And then with equations, the answer was the point where they cross. But with inequalities, we have all that shading. So the answer is going to be where the shading overlaps. Okay, and then just a reminder, slope-intercept form, y equals mx plus b, or in this case we'll have an inequality instead of an equal sign. But if it's not already in that form, we'll have to put it in that form in order to graph. Okay, and then before we start, just a couple of reminders to decide what type of line we need. If we have a less than or a greater than, we want a dotted line because those are not included in the solution. If we have less than or equal to, greater than or equal to, then we're going to want a solid line because that will be included in the solution. And then for shading, if we have a less than or equal to, we're going to shade below, or that would be left for vertical. So we have a vertical line, we'll shade to the left. If we have greater than or equal to, we'll shade above. But again, vertical line doesn't have above, so we'll shade right for vertical. Okay, so let's go ahead and graph number one. The y-intercept is -3. Put our dot at -3. Then our slope is 2 over 1. So we're going to go up 2 over 1 and repeat up 2 over 1, 2 over 1. And then this has an equal sign, so we want a solid line. We're shading less than is below, so everything down here. I'm going to change colors now for the second line. We're going to do a +2 for the y-intercept. The slope is -2 over 1, so -2, +1, -2, +1. This time we just have a greater than, so no equal to part, which means we need a dotted line going through those points. And then we want greater than, so greater than is up above. So then our solution then is going to be, where do these overlap? So they overlap here. This solid line is included, not the dotted line. And then everything in here where they overlap is a solution. So the last thing it asks us is -2 a solution. So if I put that point on the graph, -2 would be right here. Is that a solution? No, not a solution. The solution would have to be in that overlapped shaded area. Number 2, again, these are both in slope-intercept form, so we can just go ahead and graph. The y-intercept for the top one is 5. And then the slope is -1/2. So again, there's only one negative sign. So I can either make it -1 and +2 or +1 and -2, as long as there's one single negative sign. And since I can't go +1 because there's no room, we'll go -1, +2, -1, +2. And then that is just a less than, no equal to, so it means we're going to need a dotted line. And we're shading less than is below. Y-intercept for the second line is -1. Slope is 1 over 1, so up 1 over 1. And we can see these lines are going to intersect right there, but again, the answer is not just that one point, it's everything where they overlap. Okay, so or equal to, so solid line, and then greater than is up above. And the answer is, where does that shading overlap? So dotted line not included, solid line is included, and then everything in here where those red and blue overlapped is the solution. So we're checking the point 4, 0. The point 4, 0, 1, 2, 3, 4, 0 would be right here. It's where the blue is shaded, but not the red, so it's not in the overlap. So then is that a solution? no, not a solution. Okay. And then number 3, we have to get this second equation into slope-intercept form, so we're going to add 3x to both sides, because that's the opposite of the negative is positive to make that cancel. So we have y is less than or equal to 3x minus 4. The 3x was positive, keep it positive. The 4 is negative, keep it negative. So if we graph, let's just graph the one we just did. So the y-intercept is negative 4. The slope is 3, or 3 over 1, so go up 3 over 1. And keep repeating, up 3 over 1. This is an or equal to, so I need a solid line. And we're shading less than, so less than is below. And then for my first one, the y-intercept is 5. And then the slope is negative, which means negative 1 over 1. So I can make either the top one negative, or I can make the bottom one negative. I'm going to make the top one negative because I can't go up 1. So I'll go negative 1, positive 1, negative 1, positive 1. This one also has an equal sign, so they are both going to be solid lines. And then this one we're shading greater than, so up above. And the overlap is going to be this solid line is included, this solid line is included, and then everything in here where they overlap. For the ordered pair, the point 4, 4. So 4, 4 would be right in here. So yes, that is in the overlap. So is that a solution? Yes, it is a solution. Now before we look at number 4, I want to make another note off to the side here. That if we multiply or divide by a negative, we have to flip the inequality sign. So same as when we were solving regular inequalities. Anytime you multiply or divide by a negative, the inequality sign has to flip. Okay, so let's go ahead and rewrite this bottom equation in slope-intercept form. So opposite of minus 3x is going to be plus 3x. Then I still have a negative sign, negative 2y. It's greater than or equal to, that's a positive 3x and a positive 6. Here's where we need to divide by negative 2. So everything gets divided by negative 2. But now because we divided by a negative, this inequality sign becomes less than or equal to. And then I have negative 3 over 2x, and that's exactly negative 3. So let's go ahead and graph that one. My y-intercept is negative 3. My slope is negative 3, positive 2, but I can't go down. So remember, that's the same thing as positive 3 and a negative 2. So we're going to go positive 3, and then a negative 2. Positive 3 and negative 2. And that one has an equal sign, so we want a solid line. And we're shading less than now because we had to flip that, so less than is this direction. And then for our other line, y-intercept is 4. Slope is 2, or 2 over 1. And I can't go up 2, so I can go negative 2 and negative 1 because 2 negatives are the same as a positive. So I can go negative 2, negative 1, negative 2, negative 1, and repeat. That does not have an equal to sign, so we're going to make it a dotted line. And then it says less than, so we're going to shade it down below for less than. And again, we're looking for where they overlap. So not the dotted line, but we include the solid line, and then everything in here where they overlap is a solution. And then it wants to know specifically, is 0, negative 3 a solution? So 0, negative 3 is here. Since it's on a solid line, then yes, it's a solution. If it had been on the dotted line, it would be no, it's not a solution.